The degree of a polynomial also tells you how many roots, zeros, solutions a polynomial has. So when we did quadratics, we could have had 2 solutions, 1 solution, or no real solution. It also helps us to figure out the max number of real roots. That's where it does cross the x-axis. So if we have a polynomial that has a degree of 4, it could have 4 zeros. Okay, these zeros could be real or they could be imaginary. So that means degree of 4 will cross that x-axis 4 times possibly. It can have at most 4 real zeros. So it could cross that x-axis 4 times. It might not though. The only time we have real zeros is when it does cross that x-axis. It crosses the x-axis at most 4 times. Again, that's because the degree is 4. The higher the degree, the more complicated the graph is, and you can even go to Desmos and type in some crazy polynomial function like, 5x to the 18th and put some other values in there and see just how many times this graph could possibly cross that x-axis. So the higher the degree, the more curves it has. It's going to cross the x-axis more, so they really do get complicated. Speaking of curves, polynomials are always curves. There's never any breaks or corners in it. Here are some polynomial functions. Now the first one's just a constant. It's a degree of 0, and then we have our linear. That was all basically algebra 1. Then we have our quadratic, which we recapped this year. Then cubic has a degree of 3. Quartic has a degree of 4. And then quintic has a degree of 5. I want you to notice on the even degrees, and behavior is the same. Up, 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 up. Odds starts up, ends down. Starts down, ends up. So that's sort of what we did on the previous section. We looked at the end behavior. So even degrees, same end behavior. Odd degrees, they start and end in different spots. Let's just do a quick little check, see how we did. So if we have y equals 6x to the 6 plus 8x minus 3, I want you to figure out what the degree is, what the leading coefficient is. What's the end behavior? As x approaches infinity, what does f of x approach? As x approaches positive infinity, what does f of x approach? How many zeros could this have? At most, how many are real? And how many times is it going to cross that x-axis? And then try this one out. Y equals negative 13x to the third plus 2x squared minus 7. What's the degree? Leading coefficient. What's the end behavior? As it goes to negative infinity, to the left, what does y do? As it approaches positive infinity, what does y do? How many zeros could it have, real or imaginary? At most, how many are real zeros? And what's the most amount of times it can cross the x-axis? So grab a piece of paper, try those out, and I will show you the answers on the next video.